Hello again, class. This is Mr. Liao, and these are the 2017 AP Microeconomics FRQs. Number 1, corn is used as food and as an input in the production of ethanol, an alternative fuel. Assume corn is produced in a perfectly competitive market. Draw a correctly labeled side-by-side graph of the corn market and a representative corn farmer. On your graphs, show the equilibrium price and quantity in the corn market and the profit maximizing quantity of corn produced by the representative farmer earning zero economic profit. All right, so we have side-by-side graphs. We have market on the left, firm on the right. So in the market graph, we have market supply intersecting market demand at the market quantity, which is QM, at the market price PM. In a perfectly competitive market, firms have to take the market price, so that's the same price that the firms take. You have marginal cost intersecting the minimum of ATC at where demand equals MR, which equals AR. So you're in long run equilibrium with no economic profit. QF represents the intersection of MR equals MC, and that happens to be at the minimum point of ATC, indicating there's zero economic profit. B, assume the demand for ethanol increases. On your graphs in part A, show what will happen to each of the following in the short run: market price and quantity of corn, area of profit or loss for the corn farmer. So with the demand for ethanol increasing, corn is an input, and as such, derived demand applies. Whenever the demand of a product goes up, the demand for a resource or an input for that product goes up. So demand for corn increases, increasing the market quantity and the market price. Firms will accept the new market price, so the demand / marginal revenue curve for the firms go up. So MR equals MC at a now higher quantity, which is indicated by QF1, and the area of profit represents the quantity, the new quantity times the difference between the price, which is D1, and the ATC. C, relative to your answer in B, state what will happen to the market equilibrium price and quantity of corn in the long run. Explain. So in the long run, new corn farmers will enter the industry due to the presence of profits. That will cause the market supply curve to shift to the right, which will then cause the market equilibrium price to decrease and the quantity of corn to increase. Part D, soybeans are produced in a perfectly competitive market. Assume farmers can grow either corn or soybeans on the same land. What happens to the price of soybeans in the next planting season if the price of corn increases? Explain. So the price of corn goes up, that's going to encourage farmers to produce more corn, supply more farmland for corn, and supply less farmland for soybeans. So what's going to happen is the supply of soybeans is going to go down because farmers aren't planting them as much. Since the supply of soybeans goes down, price of soybeans will go up. E, assume that instead the government sets a binding price ceiling in the corn market. Draw a new correctly labeled graph of the corn market and show the following: the binding price ceiling and the quantity purchased by consumers. All right, so you have the market graph, downward sloping demand, upward sloping supply. There's QE, that's the quantity absent a price ceiling at that price. Price ceiling to be binding has to be below equilibrium, which is there. And the quantity purchased by consumers is listed as QP. So even though demand at that lower price is higher, the quantity demanded higher, fewer corn farmers are willing to sell it at that low rate. So what happens is the binding price ceiling causes the quantity purchased by consumers to be lower than equilibrium. 2. The table below shows the output of a firm using different amounts of capital and labor. The markets for capital and labor are perfectly competitive. The rental rate of capital is $75 a unit and the wage rate is $200 per unit. In the short run, capital is fixed and labor is variable. Part A, if the firm uses 1 unit of capital and 1 unit of labor, will it be operating with constant increasing or decreasing returns to scale? Explain using numbers from the table. All right, so we're looking at this box right there, 1 unit of labor, 1 unit of capital. Labor costs 200, capital costs 75 for a total of 275 bucks. Your output is 10 units, so the average total cost is 2750. Now remember, with increasing returns to scale, that means ATC is going down. So let's look at 2 units of capital and 2 units of labor. So we're looking at these 50 units. Now that's going to double the resource costs from 275 to 550. However, the output more than doubles. In fact, quintuples from 10 to 50. So the ATC drops all the way down to $11 per unit. Since ATC is decreasing in this stretch, the firm is operating with increasing returns to scale. So increasing returns to scale means that ATC is going down with additional resources. B1, assume now that the firm currently has 2 units of capital and is using 3 units of labor. Calculate the marginal product for the third unit of labor. Show your work. So we know that the output with 2 units of capital and 3 units of labor is 75 units. So with 1 fewer unit of labor, total output is 50. So that third unit of labor yielded a marginal product of 25 units. 75 minus 50. B2, did the firm experiencing diminishing marginal returns with the addition of the third unit of labor? Again, explain using numbers from the table. So with 2 units of capital, the second unit of labor increased from 20 to 50 for a marginal product of 30. To go from the second unit of labor to the third unit of labor, the increase was only 25. So therefore, the firm is experiencing diminishing marginal returns with the third unit of labor because marginal product is decreasing with additional units of labor. B3, calculate the firm's total average cost for its current level of production. Show your work. So we're told that at 2 units of capital and 3 units of labor, total cost is $750. 2 units of capital for $75 each, 3 units of labor for $200 each, $750. You're told that the level of output is 75 units. So total cost divided by quantity is the average total cost. $750 divided by 75 equals $10 average total cost. Number 3, the graph below shows the marginal social cost, marginal private cost, marginal social benefit, demand, and marginal revenue curves for a monopoly. A, identify the monopolist profit maximizing quantity and price. So you're going to look to see where MR equals MC. In this case, MC is the marginal private cost. So you're basically looking at this point right there. That's going to be where MPC intersects MR. And if you're going to go up to the demand curve to find the price, that's at P4. So the quantity is Q3, the price is at P4. So look where MR equals MC, go up to the demand curve, go left to read the price. B, what information in the graph indicates there's a negative externality? It's very simple. MSC is greater than MPC. C, identify the socially optimal quantity. So this is where MSC equals MSB. That's going to be right there. So that takes place at quantity Q3. Now notice that a monopolist tends to underproduce compared to the socially optimal quantity. But because there's a negative externality, the monopolist's underproduction is actually equaling the socially optimal quantity. So that's a quirk of this problem. You didn't have to say this in your answer. I just want you to notice this because you would have noticed that the monopolist produced quantity at Q3 happens to equal the socially optimal quantity. D1, in the case in which the government imposes a per unit tax equal to MEC, identify the dollar value of the tax using price labels from the graph. So you're looking at the vertical distance between MSC and MPC, and at Q3, which is the profit maximizing quantity, that difference is P4 minus P1. D2, what is the profit maximizing quantity associated with the tax? So now MSC is going to equal MC. It's now the firm's MC curve. So now MR equals MC at Q2. So now notice with the tax, monopoly produces less. That's the idea of a tax. It reduces output even more. Part E, given the monopoly facing the negative externality, would the deadweight loss increase, decrease, or stay the same because of the tax? So remember, the deadweight loss represents the loss of efficiency due to the socially optimal quantity not being produced. But in this case, the monopolist was actually producing the socially optimal quantity prior to the tax. So with the tax, the monopolist is producing less. So the deadweight loss is going to increase because of the tax, because there was no deadweight loss before the tax. That's it for the 2017 questions. If you have any questions, you can reach me at the many ways to reach me.